So you see like only single there are other like the double has two
ಐದೊಂದರದಿ ಇದೆಲ್ಲ ಕಿಚೂರಲ್ಲಿ
kind of so what is the drawback in a single link, right? So there is only travel in one direction, there is no backward movement, there is not go from A to the second part and the end part. So that's one drawback. That is actually overcome in these two types of things. So you can see like how different because the other data but something that is being developed and so you can explore these on your own and you can actually build programs. Basically, the competition will need another the previous one so this ends this first session. So the answer session. So we just do it in identify so just give us a couple of minutes so we can upload the ATM. Also, tomorrow we must be on our technical bridges. So we'll be able to start to start and from next week, we will start academic projects. So if we go to one and actually we all start and social so the next question is about so there's nothing but the implementation. So this is implementation. So I'll just cover some of the slides that are there in that. So before we are so this is only a 25 slide document, so it won't take much time. I'll just quickly go through our so when you have to understand and prerequisite, you actually need to know about them. So and when you are browsing the network and you want to actually move backward and forward, so let's take this example. Share my address. So let's say I'm open my tab using your program. And then give it a clicking on the screen, create a right. So I click on the screen. So we can see in the tab on the bottom side. You can see here there are two links, right? Both of them are Google Pay. Let's say I'll just type more links. Right? Again, right here. This page over. So now we are getting now let's say from here I go to some site email right. So now so all the links that I have be stored over there, right? So this is nothing but the latest link that has been that is made here. The one previous to that is over there. So one bigger than another one. Now let's say I press this button. I'm going back to the program. Now let's see what here. So last time that I got given button is over here. Right? So you can see this is nothing but kind of popping and pushing the operations that are happening. Right? So because what's happening is that link the sound channel needs to be here. Right? So what something similar to a data structure that we usually do. A similar kind of operation is the undo and the redo operation that we normally do. Like name text file or word document. We have this undo and redo, right? So where are all these operations being stored? Similarly, there is some data structure that we use. So that data structure is nothing but the bank data structure. So it actually uses the so that is nothing but the tax data structure. So it uses the last and first order mechanism and so the last and first order. So anything that you put into the tax, that will be the first thing that goes out. So let's say S was actually the first thing, or so let's looking at this thing. We see that you first open Google search, right? This is the first link that you open, and this is the last link. So, but whereas sometimes this is the last link, so this should be the first one that goes out. So let's say I click on back. I'm over here, right? So this is out. But Google Gmail.com is over there. So the last thing that I'm looking at is Gmail, right? This one. So if you can see over here, it's actually using two slides. One that actually stores the link that I'm over here, and this is actually storing the link that I'm going to see next. So this is how that actually works. So we have a last two questions. So it's pretty simple. I hope it was clear, the simulation was clear. The best thing is the undo and the redo operation. So anything that you do, the last operation that you do, it gets stored in the stack. So if you say undo, the last thing gets out. It's more of the stack. So we will look at the simulation. So let's look at EPC and read the simulation. Generally, there are two operations in the stack. One is the push, and the other is the pop. Push actually puts the element into the stack. So let's say I type in 20. So it's similar to the linked list because we are using the linked list. So this over here you can notice the change. We have a pointer called top. Whereas the linked list one we use something called head. Right? So top keeps track of the last element that is inserted into the stack. So now it says 30, which is 30. So now my top is moved to this. You can see over there, this is the last element that has been inserted, and the top is this. So now let's say I click on form. The last element get out of the stack. So now only 20 remains. So this is how the last and first order mechanism works. So whatever I get out, it gets out first. So we'll look at an example implementation of stack using linked list. So we'll actually see the program and how to implement a stack. Okay, you can note it down. You can see over here.
Font size specification.
This is something
Font size increases.
similar to the English application program that we did. Whereas over here we're calling the star and the local 10. So we want to be doing this example now because of paucity of time. What we do is we put this up on the portal. We can actually listen to this example. Just a second. So this example will be put up on the portal. We can actually see the example. We won't be doing this now because hello, please. Okay. So you can actually look into this example and you can actually give this example, put in more of your method and work with this example. So now you can also run this code and see how it works. So one thing we will actually put this up. So what we do is we'll run that code and we'll show you how it actually works. So just give me a second. So it's this implementation of pretty similar to the linked list, not the linked list. We'll say we'll insert the element over there. It's nothing but the push operation that we're doing. So it's randomly inserting some element. So again, we are inserting like 4 elements. So we'll again insert some element. Now we'll display the element. So you can see actually randomly inserted some element. So now let's say again we'll insert one more element. Now let's see what's happening. Now let's display. So now you can see over there. The cost is now changed, right? And similar to simulation 1. So 55 is the first element that was inserted, next 37 is 41, and now 69. So this is how it actually works. Actually, it's the last and first. So now let's say we remove an element. So 69 is removed, so that's the top. So this is how we can actually see it. 69 has been removed, so this is the top. Now the remaining is the element is. So now we will remove all the elements. Now let's see what we can. So we will remove 41, we will remove 37, also remove 57. Now there is nothing in the list. So what it says is stack is empty. If we are trying to remove all the elements, nothing is there, right? So stack is empty and there is nothing in the linked list. So this is how it's actually implemented. So you can actually work, use that code and work on that. And have any issues or any doubts, you can actually open on portal. We'll be there to explain the code and all. So we'll get back to our. So this is the example. We are not using the example. So we can actually work out the problem. To work out the problem,
Desktop.
So there are some workout problems for you. Then you do this workout problem. Each one will take around 30 minutes. So what we do is we can explain you this how this needs to be done. So there are some test cases. Okay. So what we do is we will already implement this code. This code will be put up on the portal. We will be implement this, but we will now show you the code. So about this program is here. Let's say you enter some parameters. The program should match rather than for every open parameter. should match whether there is a close parameter. And there are some test cases that we also need to check. Because if the page is this case, so the second test is, you can actually see that this is the wrong way of loading the parameters, right? There are two open parameters. Without closing that, you are using a create parameter. So this is the wrong way. You actually need to look at all these test cases. So your code should work for all these test cases. To ensure that you work. So we'll actually run sample code and we'll prepare the code. We'll just run that and see how it works. I'm sharing my desktop. And please note that this code won't be put up on the portal. We actually need to work this out. There is a problem now. Okay, so this is the code that we run to work.
Share.
So we'll now see how to run the code. We'll run the code. So we need now to enter the expression. So what we'll do is we'll just enter some parameters and see. So you can see over here, this is a valid expression because there are two open and there are two closed, and whatever is open is last is closed. So it says it's matched. Now let's run this code again. What we do is we'll again do this. So we are closing this and we are doing this. So you can see this is the wrong parameter matching because the curly bracket was the wrong bracket. We are being closed without even opening them. So this is a wrong way of entering this. It is not matching. So your code that you write should work for all these test cases. Also, let's say we have one more code. We run this like let's say we are running it like this. So it's actually the perfect way because there are two open, two closed, and there are again two open but round brackets and two closed brackets. But if you can see over here, this there actually being closed before the round bracket. So this is the wrong way of matching. So the code should say not matching. So you should actually work out all these, look at all these specifications and see the code works for all of these. And you should be submitting your code. Before you should be submitting. So we are not expecting that we work on this code now. We can actually work on this code before and submit it before the next quarter. So we will proceed forward. And anytime you have any issues, you can actually answer. So we will be there to answer. So moving on to the next workshop. If you have any doubts now, you can ask. Otherwise, we will move to the next workshop.
Mahinder, share start Gmail.
So we'll proceed. So this is the action problem. You can actually do it and so this is nothing but implementing the browser. I mean, like in Google Chrome, right? We have this back and the forward button. You can actually implement this in the command prompt. So like you can think of several situations where we can actually so another situation is the post application. Given a message maybe convert that to post. So this is another example of that. you can actually use it like different test cases on your code for different test cases. So all these are the expectations that you work out this plan and submit it. So that is the expectation. And normally you may have to support them in you may have to write the expectation and we use the portal, the discussion forum in the portal, and we look up the discussion forum for any issue case in the workshop related to a particular question. We post those questions to the forum and we will be there to answer. So we'll now move to the next part. So on the evolving practice process will work out. So all this will be put up on board. So now let's consider a scenario wherein there's an organization and there are two people. Let's take a scenario wherein you're working in an office, you want some prints to be taken. Let's say your print tool is actually using a CAD. And you are the first person to do a print, and your colleague person doing some print. And if you are experience of that, what happens? You will be the last person to get the print, right? Because the CAD put everything in the tool or the printer is putting all the records in the CAD. As and when you get the print, printing works and printing out so let's say you make your computer and you are getting it at the last. So isn't that frustrating? Because you are the first person to actually send and you are the last person to receive. So people thought about this, okay, not so they came up with the letter called so here is something which is simple as the name like stand in a line for getting tickets. So first thing first, you and personally you get a ticket. Similarly also, you send the request for ticket and you get it in order. If you are the first person, we use for person to get the ticket. So look at the simulation. I need to share my desktop. Look at the simulation on the so there are two operations in the queue. One is empty and the other is empty. So empty is nothing but and it is pushing the element out. Something similar to push and pop of the stack, but it's done in a different way. Let's look at that. So we just enter the line 10. So you can see over here, there again some new term introduced. One is the sign, the other is the nothing but to keep count of where the first element is and the last element is. Again, insert another element. So now 20 becomes the front. You can see over there. So 20 is now being represented as one front. We'll again insert another element, so let 30. So now front becomes 30 is represented by front. So you can see where is constant, right? Because this is the first element that was inserted. Second and third. So now let's say I become these things. What should be the element that should be pushed out or sent out of the field? Naturally, it should be 10 because it's the first thing that was inserted, right? So we become between 3 options. So 10 has been removed and sent out. Now 20 becomes the first. So it's similar to 10 is nothing but the first person who got the ticket and come out of the field. Now 20 is chance. So now let's say I delete this. The 21 person got the ticket and the new person has not got it. Now again 30. So there's nothing, there's no element in the field. Now let's say I press next field. It says Q is empty. So there's no element in the field. So this is a simulation of how Q actually works. So so this is the Q, the NQ and the DQ operation. The other one you get an element, you can actually remove it. So first in, first out. So that's how it can happen. So like entry over here, right? X is entered first, E, then B, C, A. So it's the same order where I remove. Like E, B, like that. So now let's look at an example of CPU scheduling. We also run this example now because again of paucity of time. So we'll just show you. I mean, we'll give you a brief overview of what CPU scheduling is. So I mean, like there are a lot of processes that run in the computer, right? In the online CPU. So how does the system actually use this? Use all these processes? How does the system run these processes? So it actually assigns some, let's say, we look at this example, so we can actually appreciate it better. So what we do is we will run code. Okay. Okay. So now let's look at, let's say there are three tasks that need to be done. One task one, which takes 30 seconds or 30 whatever. Task two, which takes 20 seconds. Task three, which takes 5 seconds to complete. Now the CPU gets these three tasks that need to be done. So we implemented one model code which actually runs this. So what we'll do is we'll run this code. So now see how what actually happens. So you can see over here. So we'll just wait for the task to complete. So now now you see that there are three tasks, right? Task 2, 3 and 1. So these are the tasks and the output. Yeah. So you can see over there task 2, 3 and 1. So over here seeing right task 1 30 seconds. So you can see over here task 1 has been entered over here. And 5 seconds have already been done. So only 25. Next, task 2 is in progress. So again another 5 seconds. So from 20 now it is 15. Now task 3 comes to task 3. Because task 3 is only for 5 seconds, task 3 is done, it's sent out. So now only 2 tasks remain. Task 1 and task 2. So again, in a similar way, all the tasks are being done, and we use the round robin algorithm. So that's how we can actually see we started with 1, coming to 2, then 3. So I mean, like, in the round robin fashion, we actually are working on all the tasks, doing them for 5 seconds each, and then at the end we are completing all the tasks. So I mean, like, this is how the queue actually works in your CPU schedule. So what you will put up this you put up the example on the portal, so you can actually analyze the example to appreciate it much better. So for now, we just think that all the tasks are in a round robin fashion, and each task takes 5 seconds to complete. So all the tasks are done in 30 seconds. So again, there are some workout problems for you. You can actually work out these problems. So you can implement a few data structures Q1 using two stacks, stack 1 and stack 2. So like it's you actually need to think about this. So we actually given you a hint of how to do this thing. If you observe an example or scenario that we shown. So how to implement this. So if it's not clear or you have any doubt, ask us. We'll be there to And there's one more, there's some practice problems again for you to work on. So you can implement it using the array data structure. So all this PPT will be put up, so you can actually read out and install it. So the example that we showed, it was using a linked list array or a linked list was implemented using linked list. Now what we need to do is we need to implement linked scheduling algorithm. So all the algorithm is there for you. So now you need to implement this using a queue array. So using queues you need to implement it. So you need to tweak your code a little bit and talk about this problem. And, so once you are done with all this, all these projects, all these problems, there are some projects that you need to work. So actually these problems are a new addition to our content. So I think they were there like last time, but we did migrate them to the end. So I mean, like, you can work on these projects. So I mean, like, they're basically programs that we need to work. So you can actually use like the concepts that were covered today. So linked list and stack to work on this project. So you just take a look at what these projects are, which I actually need to go on and share with you. So these projects actually are so the first project is polynomial evaluation. So actually pretty much simple. You might have done this polynomial addition and multiplication in intermediate or in the degree first year. So it's nothing but it takes two inputs which are in this format. So let's say the polynomial equation is this. We should input it in such a manner. So let's say 3x plus 4x squared plus x plus 0. So it should be given in the way. So let's say 4x cubed. So 4 comma 3. So the first is nothing but the constant. Second is the power. Yeah. Or the exponent. So 3 is the exponent. And followed by 2 columns. And 2 x squared. So 2 x squared. So 2 comma 2. Followed by 4 and column. And x. So there is only the constant is 1 comma 1. And then there is no more 0 term. So what we say is 0 comma 0. Or there is only 2 specified differences. We can just leave it as it. And the second equation what we will do is we will take up the equation 5x cubed. So 5 comma 3. And we won't have a power of 2, so there won't be any x square term. So we'll have only x term. What we do is 5x, 5 comma 1. We will have a constant term over here. So we will have 9. So we will say 9 comma 0. The constant is 9. So now let's see what will happen when we add. So the internal equation is together. So it is being represented like this. We use the linked list internally to represent this. So now let's say adding. Right? So you can see over there it's adding the exponents. So 3 and 6. So 4x and 5x. And it's adding the 9x. So 9x. Since there is no 2 power 2 term in the second equation, it's the same 2 comma 2. Okay. And we are going to so 5 comma 1 and 1 comma 1. So it becomes 6 comma 6. And then 9. So this is your whole equation. So I think once this is done, you need to display it. You need to say, okay, the addition of these two is 9x cubed plus 2x squared plus 6x plus 9. So that should be your output. So let's say you're adding. Similarly with multiplication. So you need to multiply. So you can actually see how multiplication is done. So we do another equation. We say 5 comma 2 and we say 4 comma 1. So this is nothing but 5x square plus 4x. And over here what we are doing, we will say 7 comma 3 and 6 comma 1. So over here I make 7x cubed 6 plus 6x. So let's see what will happen when we multiply these two equations. So yeah, put it into two inches. Now and it's multiplying them. So you can see we actually need to multiply each node with the other node and the other links, right? It's similar to something similar to like your multiplication of two numbers 32 and 42. You multiply 22 with the other number, right? So yeah. But you can see okay, I do one thing I will come with that. You need to understand. So how much 2 and 4 comma 1. So here it's 7 comma 3, 4, 3 comma 1. Now we are multiplying it. So what happens? I will pause it for a minute. So now what happens is this node should be multiplied with this and also with this. Similarly, this node should be multiplied with this node and also with this node. So that where we see. So these two are multiplied first, then this and this is multiplied. So we can see 5 into 7 is 35 and the exponents we just add them. So 3 plus 2 is 5. Similarly with this, 5 into 3 is 15. The exponents we add 2 plus 1 is 3. So pretty straightforward polynomial multiplication. So again now we will multiply 4 with 1, 4x with 7x and 3x. So we can solve it here. So that's how it's done. And this is how, I mean, like, this is the output that needs to be displayed. 35 x power 5, 15 x cubed, 28 x power 4, and 12 x squared. I hope this project is clear, and we expect that each project will take at least like between 3 to 6 hours for you to do. These projects might take lesser time, so that's why we want you to actually allot at least 10 hours, 10 to 12 hours after the workshop for you to work out the problem and the tasks and all. So there's one more, there's another project. So it's called the web calculator. So this project should be implemented using stacks. So there's no need for you to actually implement all this interface and all. You just need to take a PostFix notation. I'm sorry, an infix notation that I'll give you example. So let's say 956 with an equation plus 3. So this is the infix notation, right? So what you need to do is convert it to PostFix and then evaluate it. So this is how it actually is. So the stack operation of what happens is shown. So it's converted to PostFix. Now it's doing the operation. And now it's doing the operation. So this is how we actually need to implement this. So 57 is the output. This is how it's going. So you can actually make it more complex if you're finding it easy. So you can actually do it like 1950. Then you open the magic. Say 5, 2, and you can do many things here. 9, you need to implement this. So you can actually start with something simple, 9 to 6, and implement it just to get a feel of it. Then go into doing more complex applications or complex equations. Now all of this is clear. So now process is done. Now we need to implement it. So anyway, all this PPT will be there, will be shared with you. So you can actually access this PPT any number of times and will be upon portal. You can access the PPT any number of times, get a hand of what is expected and what needs to be done. So, I mean, like, basic idea is to get you acquainted with all the data structures, and give you real world problems so that you can actually learn hands on instead of not, I mean, like, just giving you see what of it. Using the science, use cube and all, and what just leave it like that. Modules to actually work out the problem and work with apply them to something real world, something that you can relate to. So I hope this session was I hope this was clear. The project what needs to be done. We'll actually put up all these PPTs, all the example problems in a couple of hours time. So you can read with us in 7 o'clock today. We'll actually put up all these PPTs and examples. And also we'll put up the upload links for each workshop. So what projects need to be uploaded, what tasks need to be uploaded. We have all the upload links as well. If you have any questions, we can take them now. So we can actually take the questions now. Also, if you want to take your time, go through the PPT, everything, want to ask a question, then post them up on the portal. So we'll answer them in quick time. Like if it's really working out, we'll answer them in say in ask them or say something. But if it's not really working out, maybe it will take some time for the question. So you can actually post any questions that you have on the portal. Or if you have any questions right now, we are here to answer your questions. Okay. If nobody will have doubts, we can close the session now. Will anyway be available tomorrow as well because we will be coming the same session tomorrow. So I have some message for the system administrators over there. So tomorrow morning we will be doing this phase 1. And for phase 1 we will be starting at 9 o'clock. So all the system administrators, please ensure that you do the testing with our team over there, Nadeem and Mr. Maninder, before before the start of the session. So they'll be available over here from quarter to 9. So we can actually work with them and if you have any issues in we can fix them. Because the session will start from 9:30. So faculty members, please members like who have undergone training, please inform your colleagues, those that are undergoing phase 1, that tomorrow session will start at 9:30. And hopefully we should be having any glitches like we had today because it was just initial hookup. So I hope the session was informative and you found it useful. You can always mail us our mail ID. I think we have nanpdu@ufit.ac.in. If you have any feedback, you can mail to this. You can mail to this. You can mail any queries that you have over there. Also, you can put it up on the portal. We will be there to answer them. Thank you, Kishore, and thank you for staying so long and coming out of your schedule and undergoing this training. We hope you found it useful and look forward to meeting you all next week. Same time, Thursday. Okay, we'll actually work out the timings and if you like maybe move it a little half an hour forward, say 1:30 to 4:30 or something like that, and keep the session short. What we intended was when we started with Google is the session or the training time would be like 3 hours and 1 hour for questions and all. So we intended the training to be from 2 to 5 and 5 to 6 would be like open for any discussions, any questions. But we find that the colleges are having some issues with the transport and all. So we'll work it out. Maybe move the session say from 1:30 to 4:30 or something, so that it will be like beneficial for all of us. So if you have any inputs about the timing, please do let us know. We are rather flexible on time, so we can take from 1:30 to 4:30. So if that is okay, please let us know. If there's nothing else, we can close the session. And good day to you all. And yeah, and please don't forget to work on the task and submit them. That is most important. So we hope you will do the task and any questions you can post on the board. Thank you. Yeah, yeah, nice day to you, Robert and college. So tomorrow's session will be taken by my colleague, Mr. Suresh. So please tell your other colleagues who haven't undergone training today to, to take the session tomorrow. So tomorrow we will start at 2, but from next week we will be informing you well in advance whether about the planning. So 1:30 to 4:30 we will inform you well in advance. Day by day, Monday morning we will inform you. Okay? Thank you.